You might be familiar with the two-dimensional rectangular system, even the three-dimensional rectangular system, but what about the cylindrical coordinate system and the spherical coordinate system? We're not really going to go over what those are in this video, but more so we're going to do some practice with them, so hopefully you have some degree of familiarity already. And what we're doing in these exercises from the Larson Calculus book, 8th edition, what we're doing here is essentially converting from these rectangular coordinates with x, y, and z to cylindrical coordinates, which if you know they have r, or just write a little smaller than that maybe. But basically in cylindrical coordinates, you have r, you have theta, and you have z. And in spherical coordinates, so like this, you have rho. So it looks like a p, but it's rho. You've got theta, and now you've got phi, and they're defined in different ways. So one important thing to note, when you're going from rectangular to cylindrical, and actually just for the sake of it, I should write this as well, x, y, z, right? So rectangular and cylindrical, the z values will always be the same. In spherical and cylindrical, the theta values will always be the same. So sometimes you don't have to do all that work, and you can just do two of the three, and then you'll get the third automatically. No such thing between these two though, right? There are still relationships between rho, theta, phi, x, y, and z, but they're not as clear cut as just theta equals theta or z equals z. Anyway, let's get started with the first one. For question 97, part A is quite straightforward. The main thing to know is that just like in a two-dimensional polar system, x squared plus y squared is r squared. So x squared plus y squared equals r squared, which means r squared plus z squared equals 16. So that's our part A. That's all we need to do. We just convert it into cylindrical coordinates with rz. There's no theta here whatsoever. And just for fun, like in case you were wondering, this the equation over here, x squared plus y squared plus z squared equals 16, would be a sphere centered at the origin with a radius of 4. And you'll see that rho is actually defined, so rho squared is equal to x squared plus y squared plus z squared. And so from here, it's pretty straightforward to see that rho squared is equal to 16. That's literally all it is. And of course, we can simplify that, right? Rho is like the radius essentially of a sphere. That's why it's called spherical coordinates. That's one way to think about it. And so we can recite this as rho equals 4. With that, we're done with question 97 altogether. So let's move on then to the next question. My network's a little laggy right now, so I can't really write anything, unfortunately, but it'll be back soon. Yeah, it's back now. So 98. Over here, very, very similar tactic that we'll use. X squared plus y squared is r squared. So all we have to do is 4r squared equals z squared. And over here, depending on like exactly how you're graphing it, you can just simplify this to z equals 2r. That would also work, or it would be plus minus 2r. It depends on the specifics, but the main idea is just, again, x squared plus y squared is r squared. How do we do this with spherical coordinates? So that's a little bit trickier. And for that, we're going to have to kind of now draw into the definitions of what spherical coordinates are, specifically like converting between rho, theta, and phi. We do it the other way. So what is x? X is defined as rho, then you have a sine phi and a cosine of theta. Y is same for the first two things, and then you've got sine theta. The way I like to remember this is just like x is r cosine theta, it's rho cosine theta. Just like it's y is r sine theta, it's rho sine theta, and then you've just got an extra sine phi, and then z rounds it off nicely with rho cosine of phi. Right, so this is what we have. Let's just go ahead and plug this in and see what we get with that, right? So 4 times x squared plus y squared. So I'm going to rewrite it because I'm going to be going off screen now. So let me just rewrite that here. 4 times x squared plus y squared equals z squared. Right, it looks a little messy, so I'll draw a line there. Okay. X squared, so we'll keep the 4 out. X squared would be rho squared sine squared phi cosine squared theta. And then y squared would be rho squared again sine squared phi. And now not cosine squared theta, but sine squared theta. And what would z squared be? Z squared would just be rho squared cosine squared phi. Okay, cosine squared phi. What do we do now? The first thing to notice is that there's a rho squared sine squared phi, rho squared sine squared phi is common, and then you've got cosine squared theta plus sine squared theta, which is 1. So the entire left hand side can just be simplified to 4 rho squared sine squared phi. What do we have on the right side? Right side, it's just rho squared cosine squared phi. Rho is not going to be 0, so we can just go ahead and divide by that, cancel that out. Divide both sides by, there are different ways of going about it now. You could just divide both sides by 4 cosine squared phi, and that's going to give you tan squared phi is equal to 1/4. Again, actually over here there might be some restrictions on phi. I'm not fully sure. So you could probably, I think you can take the square root, and that'll give you tan of phi equals 1/2. So phi would equal the inverse tangent of 1/2. I don't think you can have tan of phi being negative 1/2. I don't think that's possible. In case it is, it might be useful to just look that up. I'm not fully sure. I should probably research that before doing this video, but I think we're good with this. Let's move on to the next one. And that question is, so this is A and B. Oh, did we do it in? Yeah, okay, sorry. I realized I didn't do it in Rick. Oh no, I did. Never mind. So question 99 is, I think it's x squared plus y squared plus z squared minus 2z, I think, equals 0. Let me just confirm. Yeah, it's that. It's similar to completing the square in 2 dimensions, only now it's obviously in 3 dimensions, x, y, and z. All we do is add 1 to both sides. That gives us x squared plus y squared plus z squared minus 2z. Sorry, every time I stop typing, it stopped writing and I start talking, so that's because of the Wi-Fi issues that I'm having. And now, yeah, this you could just simplify. You can try to guess what this graph would look like, and you'll probably get it right. It's very similar to the first question. All it is a sphere. Only now the center is slightly shifted, right? The radius is going to be 1. The center is now going to be 0, 0, 1. It's shifted 1 up in the z direction, so like shifted up like that. Okay, we're not done yet. We just need to put this into polar and cylindrical coordinates, and that's quite easy. This is literally all we do for that. What about with the what about with spherical coordinates? X squared plus y squared plus z squared. Like I said earlier, that is just rho squared. So we know rho squared minus 2z equals, one second, minus 2z equals 0, which means rho squared is equal to 2z. What is z now, right? What is z? Remember that z is just rho cosine of phi, right? And if this is the case, we can just plug that in, right? This is z, not 3. So plug that in there. Rho squared is equal to 2 rho cosine of phi. Divide both sides by phi, by rho, because rho is not 0. And so over here we get rho is equal to 2 cosine of phi. And that's it. That now it's in spherical coordinates. Last question that we're going to do here is x squared plus y squared is equal to z. This is question 100, I think. X squared plus y squared is z. You should by now hopefully be able to get that this is just r squared equals z. That's literally all it is for spherical. A little bit trickier with the spherical coordinates. X squared plus y squared, if you go back up here, I could have showed it, but x squared plus y squared is just rho squared sine squared phi, right? That's all it is. So rho squared sine squared phi. And what is z? Well, z is just rho cosine of phi. Divide both sides by phi, divide both sides by sine squared, divide both sides by rho sine squared of phi. And that's going to basically give you rho is equal to cosine of phi divided by sine squared of phi. And this is a satisfactory answer. If you want to make it a little nicer, you can rewrite this as cotangent of phi, because that's cosine phi over sine phi times 1 over sine phi, which is cosecant of phi. So that would be an equivalent answer. I'll just rewrite it here nicely once. And so this would also work. This would also be a correct answer. Hopefully you got a sense for, like, some of these are much easier than others, right? Like this what we did over here, there was quite a bit of, I mean, not much work, but if you like, so if we didn't know that x squared plus y squared is rho squared sine squared phi, we'd have to do the algebra and then see that. So there would be quite a bit of work in this one, but on the other hand, like x squared plus y squared equals z, to put that into cylindrical coordinates is a very simple task. Literally, all you do is replace x squared plus y squared with r squared, and you're done, right? So some of it is easier than other parts, and I know we didn't really do anything directly comparing cylindrical and spherical coordinates, but hopefully you still got an appreciation for how these different systems work. And if you want more videos like this where we maybe try to graph these or do such things, let me know down in the comments. And thank you so much for watching. If you've stayed with me this far, please make sure to like the video and hopefully subscribe so that you can stay tuned for more such videos. Thanks so much for watching. Bye bye.